All right, we're here with Henry Peck, president of Geiger.
Good morning. It's a great day.
It is a great day. Looks like you got about 300 people here, or maybe a little bit more.
We have a little over 300 customers here.
That's unbelievable.
They're all here. We're sold out. Almost no shows. All the rooms are packed. It's just going very smooth, almost too easy.
There's fantastic interaction going on between all the end users and the instructors. And
In fact, they're all ducking off into the room right now. It's 2 minutes to class time, and just like soldiers, they all go in there to learn, and it's quite an honor.
Yeah.
It's a very nice day.
Well, if class starts in 2 minutes, give us a 60-second overview of what we're standing in front of here.
Okay, well this is actually live order. So what we're doing here is we're building an engineered skid. We're pumping sodium hypochlorite, so it's very precise and corrosive pumping that we're trying to do, or we will do. These are magnetic sealed drives, calibration columns. If you look close, you'll see that we're running everything here. You'll see that it's actually separated here. We're going to assemble it here for running, and then we put it back together in the field. But when the customer gets is a precise engineered system, and everything is documented, SolidWorks. We have bill of material for every item. Everything is ISO 9001 manufactured in-house, and the customer will have it all pre-run here and witnessed. We run everything here before it goes out to the customer, so we know it works here, and it's just a matter of executing as an installation when it gets to the field. So this is a repeat customer like most of our products, so this is a really good
This
system.
is really impressive, and it's also, we'll also get a video of the time lapse of you guys putting it together.
Yeah,
So
that'd be fun. We usually
really
don't do that, but that'd be extra fun.
That was really neat. All right, thanks, Henry.
Box comes with a seal drawing, and that seal drawing identifies the seal that's in the box. And most of the time, it'll give you materials and construction of all of the components within the seal. It'll give you the seal size. It'll also give you some critical dimensions that are used for the sizing and selection of the seal. So, if you ever have a question on a mechanical seal, generally you can refer to the seal drawing, which is in the bottom right-hand corner, and many times there'll be a part number associated with that drawing as well. There are some generic drawings on the market. These would be for seals that could be used for many different types of services, and they were not designed for a specific pump. In that case, you won't find the materials and instruction on there, but you'll find a detailed list of all the components. All right. On this drawing, what the dimension we're looking for now is, so we know where the face of the stuffing box is sitting, right? We know that, we have the mark. We still need to know where are we going to position the primary ring of the seal. There's a dimension on the drawing, which I'll show on the big board, but it's referred to as installation reference. And that dimension is 0.062, okay? That dimension is what we have to take off of that scribe mark, all right? Now, where does that dimension go? Okay, you have your shaft sleeve, right? You have the larger opening on the shaft sleeve, and then you have a more narrower opening on the shaft sleeve. That narrower opening butts up against the impeller. And that is sealed by an impeller O-ring or gasket. In this case, it's an O-ring. That O-ring, every time you take the impeller off, that O-ring needs to be replaced. Generally, that's going to be a Teflon O-ring. So Teflon really has no memory. Once you compress it, you can try to compress it again, but chances are it might not work. So what will happen? If that's not sealing, and you have a stainless steel shaft sleeve and a steel shaft, well, you're going to get leakage that comes out between the sleeve and the shaft, and it might appear as a seal leak, where in fact it's really an impeller O-ring issue. So, okay, so now you have your scribe mark. You want to measure back 0.062 inches, and you want to measure back toward the narrower opening of the sleeve. or the opening of the sleeve that would be closest to the impeller. So again, measure .062 off of your stride mark, going toward the narrower opening of the sleeve. .062.
All right, we got Jane Alexander and Ed. And Ed. Hey, Ed. And we've got a great table here. Yeah, these guys are awesome. And we're in Henry Peck's class, which is centrifugal pump, assembly, repair, power in. So we're turning on the power here at the Pump Symposium
That's the directions say, and the oil reaches
in
the
Ashton,
ball to the bottom.
Pennsylvania.
Lower than that, you got no oil, you won't last.
Oil
You won't last at all.
comes into
Not gonna work, okay?
there, okay.
Too much over, it hits the shaft. It doesn't burn oil, guys. It's not your car. It's got to go somewhere. It'll probably leak out the labyrinth harmlessly. If you say, oh, my pump has an oil leak and it's coming out the labyrinth, it's probably not the labyrinth's fault. It's probably just overfilled. Harmless condition. It'll leak down in this case.
These hands-on classes are really what make this symposium unique and special. Very engaged audience.
It's probably harmless. It'll leak down to the right level anyway.
Actually, they got the thing on the wall. Come here.
At this point in our lives, we have
This
a
should be at
perfect
the bottom
shaft,
so the oil can
and we've got
rise. See
bearings
where
we'll never use again.
that dip is? That should be
You're
like
blessed
that.
to
So
be
the oil
here
can
and
run
see
out.
the inside of the
Labyrinth.
but it's a
Labyrinth is
dirty
like a
environment that we're going to wreck these
channels the
bearings,
oil
take them
to
off,
that.
and in the real
And it
world,
runs
you take them
back
off, you're going to throw them away. So you can be a lot more forgiving taking bearings off and putting them
The
on.
dip should be at the bottom.
Right? You're going to throw them away. You're always going to throw them away. At this point, you're always going to throw your bearings away.
How many years have you been
So
doing
there's some things that we're going to do that
I
you
don't
can get
know.
away with
Long time.
taking a bearing off.
Huh?
Namely,
Been doing it for a
when
while.
you look at a
Yeah,
bearing,
they came out and
it has
said,
an
we're
inside
sending
and
you to
outside
flight
race,
school.
and the
But the boss
tolerance
is new. He don't know how much.
That's right.
They're not 1,000, they're
He
not a
didn't
half
know.
thousand, they're not
And I
something we
knew.
can measure. It goes down to a tenth of a thousand. A sheet of paper is only 2,000 or 3,000.
It's never too late to learn something
Bearing
new.
races are fabulous. So the ball runs against the machine surface on the ID and OD, and they're perfect.
You don't really
Yeah,
need
there's
it.
so many great
And when you
experts
put the
here.
pressure on it,
It is
that
amazing
ball
the
is
knowledge
sitting
in
on a
this
film of
room.
oil between it. But if you put the pressure on it too much, like you tap it or something like that, a little bit, not sure, maybe too much, hammer on it, the ball, you look really close. If you're you're way down in there and you're looking at those molecules, that ball is resting on a metal surface and you're dinging it, which is just a small spot that it hits on. So at this point, when you press it off, you're wrecking the bearing, okay? So I understand that. When we put them back on, we're going to use these used bearings because we're accommodating classroom environment. No problem. But just to give you a perspective on what we're doing, is we're looking inside the pump, but we're not really putting it back together to put back into service. We're coming just a little bit short of that. Okay, Steve? This is Steve Justice. It's his life. I just get to do this because it's my first class and I like to do that. But I'm going to hand the mic off to Steve and he's going to get into the best part, quite frankly, and I'll catch up with you. Ready, boss? Like that.
Bring a puller on, it's going a little bit like this, okay?
So we're back at the power in session of the centrifugal pump assembly repair class. Steve Justice is now taking over,
As Henry said earlier,
and Jane Alexander is still hard at work with her
We're
team.
gonna put a wrench on it, we're gonna muscle it out of there. The more you pull it, the more you turn this screw in, it'll pull that bearing off. Okay? It's a slow process.
You want it to be able to slide.
You're not gonna enjoy it.
So we gotta take these
But
off.
you're
So
gonna
we
do
can
it.
set tweakers on there. We're gonna just take one off. Spin it.
How do you like that struggle?
Jane got really lucky to partner
Slow
with
is
someone
easier
who's also
when
a
you're doing
teacher.
magazine, right?
Flip it over. Yep. So you getting it? Slide that right in
We're
underneath.
gonna wait and show how easy it is to do the press.
Sorry. Turn it the wrong way. We need to spin that down for a moment. Spin that down there quickly.
Hopefully, you wouldn't quite be wrestling
Good
like
job,
this.
Jane.
This is how I wrestle out in the field. Can you put bearings in my pump out in the field? No. I don't do it like that. Way too much work. Way too much work.
Come on, come on down a little bit more yet. Still need better inches. There we go. this side
And
first.
bud. Well, you know what?
And spin that out a little more for me.
Put it in press.
Let's do it by hand.
Okay. So they're relatively inexpensive
Now we need to put
cores.
that nut and washer back on this other side.
This is a tight fit. As Henry said, they're probably about a half a thousand press fit on there.
Washer first.
Half a thousand is quite a bit. We got steel to steel. There's no joke about it. Now we did some of these in the shop.
You were right
Tested
there.
them. We're ready to get them all.
There you go. None of that.
Who's got them all? Who's got them all?
I know. There we go. Now we're in a good spot. Go ahead and tighten that down a little bit. See, I think it's going to be this one.
That thing up and put in the press. You're going to put it in the press anyway. You're in the press table.
Go ahead and tighten it down a
We
little
got
bit.
one up there. How you guys making out here? Coming on? Yeah, that's where I'm building some of these because I see people struggling. We did this in the shop. It did work, but we didn't do every pump, so I don't know. Someone might have to take a fit tonight.
Turn this. Got 11/16 and 3/4.
Look, we got a few guys that are struggling to get those off with the cords.
That's on slid down.
Hey Gary, let's go ahead and get the press moving. We got a few people that need some help, so we're gonna go ahead and press off more than just the 2 or 3. We're gonna press off a whole bunch of them. Bring these over here and get started.
And so we want to make sure we're not too tight. There we go. Oh, they got a press. And then we can tighten that right into that.
Dave's got a press going over here. Yeah, let's go ahead and press some of these guys off.
And I
We
think
got
it's
more
going
than
to be
just
this wrench.
2 tables. Some of these guys are struggling
Put
with
it on
the
that way so that way it doesn't pop off on you. You don't need a press. Okay, give it a turn.
Get some leverage, Jane.
I think you're okay. I don't think anything.
Use your legs.
Bottom bar. You have a plug or something. There you go. Now I'll trade you.
Let's line them up. Let's get a couple of them in there.
Can we grab this from you?
Take the cross bearing off. Take just the cross bearing off.
You're gonna hang yourself in the charger.
I know, I'm afraid to get caught on something.
This doesn't look easy. So what are we doing here?
Pulling the bearing.
Ah.
It's a big, you're not recording it. PIA.
Just bang it off. You're lucky enough to have a good press. Obviously, some of these are tighter than others. In the real world, you're gonna
Well, they got a bearing puller over there. They got a press.
That's a bit of a disadvantage because we don't have one of these presses. We have to use our muscles and our own power, right?
use the press, Ed?
Yeah, I think I'm going to use the press.
Yeah, no sense in busting your nut.
All right, tell us why this takes so long to accomplish. And remind us what we're doing.
Part of it is all your checking the parts. You want to make sure that you have the correct fits. If for some reason there's more wear, even a couple thousandths wear, that will create a little bit of a slippage inside that housing where this can spin. While that's spinning, that will create heat, which then will either lock this up, but what happens is the oil can't take away that heat. So the oil won't be able to do its job properly because there's more heat than what it's designed to have. So when you have heat inside of a bearing, then everything will swell as it it swells, it tightens up. So then that's when your balls aren't rolling inside the bearing, they're sliding inside the bearing. And once they do that, it creates more heat and it just self-perpetuates to the point where it locks up and it won't move anymore. So once a bearing locks up, it's completely garbage. So you have to throw it.
So learning how to do this is pretty vital.
Yes.
Yeah. And tell us your name again and what you do.
My name's Ed, and I'm from GAF, and I'm a maintenance technician.
Okay, fantastic. Thanks. Jane, you gotta put some muscle into it. Hit it harder. Go around the other side where Ed is. So you can get some swing. There you go. That's better. That's good, Jay. Let Ed do it. See what happens. Do we get it?
I thought it felt like it stopped. I'm like,
Do we get it? All right. Yeah.
Take it apart. You don't have to put the bearings on any further than where you are. I think we've seen how the fit is everything.
Good job.
Fit is a very prescribed fit. It isn't loose, it's a press fit. Now, what we can do, and we don't have enough accommodation here, so Gary, you can just take a break. We don't need to do it anymore. Anybody hammering back there, we can just take a break. Leave it like it is, it's cool. We got to put new bearings on and all that. We got the point. It's a class for that.
You did good, Jane.
Fellas can take a break here. Now, if you can turn your heads left or right, who's got the bearing heater table? Put your hands way up, bearing heater, guys. Right there. There you go. Now, you guys with the bearing heaters are special. Because this is the way I would do it. Instead of being an interference fit, what we do is we take the bearing and we increase its size by warming it to an exact amount that allows it to slip fit, just like that shaft sleeve over the shaft. How hot is that? It's very specific. It's a little over 200 degrees, but less than 250. There's a point when you don't want to go any hotter because what you've done is you've ruined your bearing. It heats too much. It doesn't like it. It starts to bind, and again, those magical fits are lost. The bearing balls hit the bearing housing, and then they don't come back perfectly. So what you do to do that is you measure the temperature as it goes up. These are bearing heaters, very common in every shop, and you put it on there and through electric induction. It's just 110 volt. It makes the item hot, uniformly hot. It's metal, so it goes up uniformly. Steel's it's nice about that. You don't have a steel pan, you get one in hot, the whole thing becomes hot together.
That's an idea.
There are waxes, and you put it right on there, that melt very easily to the eye at a certain temperature. We have 212 degree bearing waxes on there. And when it hits the temperature and goes above that, you know it's hot enough. And when the bearing's hot enough, with welder gloves, somebody can grab that bearing because it's that hot. And it drops right over the fit, and it goes right to the shoulder right then. You've got not too much time though, and you mech it up, you got to press it off and throw it out and start with the bearing. But because we're all watching, they're going to get it right the first time.
No pressure.